Hello, my name is Ciro Rodriguez. I will talk about algorithmic efficiency indicator for the optimization of roadsides. Uh, in software development, sometimes experienced programmers have difficulty determining before performing their test which algorithm will work best to solve a particular problem. And the answer to the question will always depend on the type of the problem and nature of the data to be used. In this situation, it is necessary to identify which indicator is most useful for a specific type of problem, and especially in road optimization. So, uh, we will introduce conceptual frame and methodology. We talk about the indicators. We explain the results and make the conclusions. In this stage, the type of problem and nature of the data to be used is necessary to identify which indicator is the most useful for a specific kind of problem, and especially in road optimization. As explained, are several ways to make the selection, but in machine learning, cross-validation is one of the most commonly used. It was finding that the best set of parameters like space, cross-validation, metric accuracy, it is important to formulate, evaluate, and compare the values of the parameters. After the evaluation and comparisons, it is possible to choose the best alternative as shown in this figure in the question how to select a machine learning algorithm. What do you want to do with your data? So you have to need an algorithm search, and in additional requirements, the accuracy, training time, linearity, and number of parameters and number of features. When we talk about the algorithm of the search, we think in the search of the most appropriate algorithm to implement in the road optimizer. We will have three candidates for the best indicator: the algorithm efficiency, the size, the road obtained, and the following relation derived from the previous indicators. The witness search is expensive, and therefore the witness search is usually aborted after the certain number of steps. In the figure about construction and open source, choose a pair of X and Y. It is considered the first and a shortcut the pair X and Y. With the way 3 is inserted if the pair X and Z is considered first and H, with way 2 is inserted. This shortcut is the part of the witness X, Z, and Y for the pair XY. So the shortcut X and Y is that node added of the pair is considered first. In the second figure, we show the result for using the Dijkstra algorithm in the graph, which represents the minimum sum of H to get from the node 0 to node 2. However, it is not the most efficient of the algorithms presented in the search paper. In conceptual frameworks, we consider important the artificial intelligence and data sets, because forecast says that in the next decade there will be approximately more than 150,000 million of sensors connected to the network. This data help all devices of artificial intelligence to think as we think, accelerating the learning curve and automation of data analysis, which all the processed information considering as much data the system receives, more learning and accuracy becomes. The lack of data sets is another concept that we need to explain, because the ability to manage the large volume of data source is enabling the capabilities of artificial intelligence and machine learning. However, some organizations cannot yet exploit all the capabilities of artificial intelligence for various reasons. One is the lack of data ability. Another is the limited sample size negatively affected their abilities, and the lack of appropriate technologies to analyze the massive data in milliseconds. Another concept is algorithmics. Algorithmics, knowing what problem is going to solve, is only half of the job. In dealing with problems, they generally do not have a precise and straightforward specification of them. So problems such as creating a gourmet-worthy recipe or preserving a work piece may be impossible to formulate in a way that supports a computer solution, although it is believed that the problem can be solved on a computer. It is usual that the distance between several of these parameters is at least considerable. Basically, in an algorithm, we consider how is the input and the output that we want for resolve the problem. So we need to understand also the algorithm complexity that represents the number of resources that an algorithm needs to solve a problem, and therefore allows to determine the efficiency of the said algorithm. It's not referred to a difficulty of design algorithm. The criteria that will be used to assess algorithm complexity do not provide absolutely measures, but measures relative of the size of the problem. What is relevant at first is the measure of temporary complexity in terms of the input data. When the problem is resolved, there is often the need to choose between the several algorithms. How should you choose that algorithm? Two objectives are often contradicted: that the algorithm is easy to understand, code, and debug, or that the algorithm efficiency uses the computer resource, and in particular that it be executed as quickly as possible. Another concept that we use here that is important is a graph G, that is a set of points in space, some of which are linked by lines, and formally the graph G consists of two finite sets N and A. N is a set of elements of the graph, also called vertices or nodes, and A is a set of arcs, which are the connections that are responsible for relating the nodes for the graph. In methodology, we talk about the shortest route, but researchers consider that the shortest route problem is a central problem within the area of networks due to variety of practical application, the existence of efficient solutions methods, and the use of subroutines if the search for the right solution is complex problems. So in minimum path algorithm, we work with the Navy algorithm. The Navy algorithm for directed graphs has reasonably good efficiency. However, it cannot be seen beyond the node following the current one of the networks. It's an algorithm that starts from the source node and goes exploring the path of the rest. And another Another one is the Dijkstra algorithm. In the Dijkstra algorithm, we use all the information and we try to identify the minimum path algorithm. It is a model that is classified within a search algorithm, and its objective is to determine the shortest route from the origin node and any node in the network. Its methodology is based on iterations, so that in practice its development becomes difficult as the size of the network increases, leaving it a clear disadvantage compared to the optimization methods based on mathematical reprogramming. Here in Z, we have the print algorithm that, giving a related graph, not directed and weighted, finds a minimal expansion tree. This is, it can find a subset of the edge that can form a tree that includes all the vertices of the initial graph, where the total weight of the edge of the tree is the minimum possible, given the set of nodes n and a set of edge e, and the cost function p of our network graph G is defined to apply the Prince algorithm and solve the problem of the minimum expansion tree. All costs associated with the edge mustn't be negative. Uh, in this table, we show the results quantitatively, and we show the data obtained from a previous study regarding Dijkstra algorithms and others. Subsequently, the values will be extrapolated on the cases of the Navy algorithm of complexity O and prim of complexity O, using the theoretical complexity of each of these algorithms. So, the results of performance timing algorithms for different graphs shows that this is adapted from the library applied protection problem, because non-native algorithm does not consider the comparison to obtain the shortest distance with the adjustment nodes. Unlike the others, it is the most efficient with the relative efficiency of O. Initially, it was enough to analyze one of the indicators to choose the algorithm. In the procediments, we found the algorithm. Here is 1 over algorithm efficiency power p, the parameter p, times the road size powered to parameter q. When solving the problem and the selection of the road optimization algorithm, if the algorithm efficiency indicator is the guide, we will obtain that the recommended algorithm is navy, but this algorithm is in turn one of the longest roads. Despite being the most efficient, it is not the right algorithm to solve this type of problem. And by following the criterion of the size of root, we are not certain that we have the optimal efficiency with this formula. In the nutshell problem, we saw how the apparent contradiction of indicators was solved. Similarly, for the problem of selecting algorithm in route optimizers, it is proposed to establish a relationship between algorithm efficiency and the road size, thus generating a new creation. A third indicator is proposed through the relationship of the previous two. We have both indicators in the denominator because it seeks to minimize the size of the road and seeks to minimize complexity, thus optimizing algorithm efficiency. So the parameters P and Q serve us to graduate the level of importance that we will give to each indicator. For example, for a brute force algorithm, it is advisable to assign at least the value of 2 to the parameter P and our root optimizer value of the parameter q, note it should be less than 3 due to the great importance of finding the minimum root emergency. After we analyze the results and graph each one of the algorithms, uh, in discussion, we found that there are a contradiction of the indicator's algorithm efficiencies. And our road sites, different criteria recommended different algorithms, which seems to show an apparent contradiction. A similar situation is presented in fractional snapshot problem, where given every n elements in which way and benefits, and given a snapshot capable of holding elements up to the maximum of weight n. That is, we want to find the proportions of the n elements. That is, we must find values that the benefit is maximized, taking into account that the sum of weight cannot exceed n. In conclusions, after evaluating these algorithms, initially it was enough to analyze one of the indicators to choose the algorithm indicated for the minimum root problem. Then there was an alleged contradiction between the results of algorithmic efficiency and road size. However, through the key snapshot problem, it was discovered that the relationship between these indicators could be established, and we can also accommodate it to different scenarios through the parameters P and Q. In the search to contribute with the fruits of this study to the solution of various graph problems later with the results of the algorithms selected by the indicator, we can form consistent data sets that know its current to the future of techniques artificial intelligence. Thank you very much